Hi there, how are you? I hope you're doing good. Welcome to today's math episode. Are you ready? But before that, let me just give you a few minutes to prepare and make sure to have with you your printed module so you can easily go along with the discussion while watching this video. Moreover, before proceeding to the other parts of your printed module, answer first the pre-assessment test consisting of 15 multiple choice items. The key answer is also provided on the back page of your module to support and guide you in learning. Thus, you are reminded to answer all the activities with utmost honesty. After accomplishing each task, you may check your answers. Put a check mark if your answer is correct and put an X mark if your answer is incorrect. Please be reminded also to use separate sheets for your answers. It is also important that you already accomplish the first module that was given to you because it is a prerequisite of today's topic on geometric series, specifically finding the sums of the terms of a given finite or infinite geometric sequence. So at this point of time, I know you're ready. Let's have a brief recap of the previous lessons discussed by answering these questions. Here's the first question. What is the common ratio of the geometric sequence -1, 6, -36, 216, and -1296? The common ratio of the given sequence is -6. If you got the correct answer, congratulations! Give a thumbs up to yourself. Next, write the rule for the nth term of this sequence, -2, -4, -8, and -16. Alright, check your answer if you got this nth rule. A sub n is equal to -2 times 2 raised to n minus 1. Got it? Congratulations! I hope you can still remember the lessons previously discussed. If not, feel free to flip the pages of your previous modules. Moving on, let's define the terms that we will be using in this module. Let's start with geometric series. Geometric series refer to the sum of the terms in a geometric sequence. It has two types, the finite geometric series and the infinite geometric series. Finite geometric series refers to the sum of the terms in a finite geometric sequence. And what is a finite sequence again? It is a geometric sequence with a definite number of terms. Infinite geometric series refers to the sum of the terms in an infinite geometric sequence. And what is an infinite geometric sequence? It is a sequence with an indefinite number of terms. Now, I will present to you the different formulas used in finding the sums of the terms in a finite geometric sequence or finite geometric series. The first formula is used when the number of terms, the first term, and the common ratio are known, and take note that the common ratio is not equal to 1. The second formula requires the first term, the last term, and the common ratio which is not equal to 1. This formula does not require the number of terms. The third formula is used when the common ratio is equal to 1. And when the common ratio is equal to -1, then we have the following formulas. But take note that if the total number of terms is even, the sum is equal to 0. While if the total number of terms is odd, then the sum is equal to the value of the first term. Here are the symbols or notations used in each formula. Let's have examples. Here we go. Let's begin by identifying what we know. We know the first term, which is 2, the common ratio, which is -2, and the number of terms, which is 5. So what formula should we use? You're right, we will use the first formula. Okay, now let's substitute the given. So we have s sub 5 equals to 2 times the quantity 1 minus -2 raised to 5 all over 1 minus -2. Let's simplify. -2 raised to 5 is equal to -32. 1 minus -32 gives us 1 plus 32, and that is 33. Multiply it by 2, it gives us 66. Then divide it by 3, that gives us 22. Therefore, the sum of the first 5 terms of the given series is 22. By the way, you may use your scientific calculator in computing. Second example, find the sum of the geometric sequence 48, -24, 12, -6, and 3. Again, let's determine the given first. The first term is 48, the common ratio is -1/2, and the last term is 3. What formula should we use? We can use the second formula. Okay, substitute the given, then simplify or perform the indicated operations in the formula. Thus, the partial sum of the terms of the given sequence is 33. This time, it's your turn. Determine the sum of the first 6 terms of the series. The first term is 1, the common ratio is 3, and the number of terms to be added is 6. Now, I'll give you 30 seconds to do it. Are you done? Okay, so what formula did you use? You're right, it is the first formula. Substitute the given, then perform the indicated operations. Therefore, the sum of the first 6 terms of the sequence is equal to 364. Did you get that right? Awesome. If not, keep trying. Okay, now let's move on to the sum of infinite geometric sequence or infinite geometric series. So here we will only use one formula. Take note that the common ratio should be greater than -1 but less than +1, because if the common ratio is greater than 1 or less than -1, the infinite series does not have a sum. To further understand that, let's have examples. Find the sum of the geometric series 3 plus -9 plus 27 plus -81 plus. Begin by determining the common ratio. So we choose -9 divided by 3, that is equal to -3. Since the common ratio is -3 and that is less than -1, this geometric series does not have a sum, or the sum does not exist. Next example. Find the sum of the geometric series 20 plus 10 plus 5. Again, start by determining the ratio. We choose the second term. Divide it by the first term, so 10 divided by 20, that is equal to positive 1/2. Since the common ratio is greater than -1 and less than positive 1, this geometric series has a sum. Now, we can use the formula to determine the sum. Substitute the given, the first term, and the common ratio. We have now 20 divided by the difference of 1 and 1/2, which is 1/2. Get the reciprocal of 1/2, that is 2, then multiply it by 20, that gives us now 40. Therefore, the sum to infinity of the geometric series is 40. And we can say that the sum does exist. To summarize, whenever the absolute value of the common ratio is greater than or equal to 1, the sum of the terms of an infinite geometric sequence does not exist, or it has no sum. Now it's your turn. Determine the sum of the series. I'll give you 30 seconds to compute. The time starts now. Alright, let's see what's the sum of the given infinite geometric series. So, find first the common ratio. Since the common ratio is 1/3, then this series has a sum. Substituting the given in the formula and performing the indicated operations, the sum to infinity of the geometric series is equal to 3/4 or 3/4. Thus, the sum does exist. I hope the discussion and examples are clear to you. By the way, there are additional examples provided in your module, which include real-life word problems involving sums of the terms of a finite or infinite geometric sequence. So you may now work on your printed module. However, if there are concepts that are not fully clear to you, you may ask or seek the help of your elder siblings, your ate and kuya, your guardian or parents, or you may contact your math teacher. There you go, our dear learners. Thank you for watching, listening, and participating today. Don't forget to watch and listen again to our next episode on solving problems involving sequences. This is your teacher Robbie telling you to keep calm and just enjoy learning.